I had to interrupt the video and start again. Any questions on the previous problem? It was quite long. And we said 38, very good. So 38 on page 141, limit as x approaches 0 from the right of tangent inverse of natural log x. Let's again refresh our memory on how to graph natural log and tangent inverse. I refreshed your memory on 1 over x. Now this is natural log. And we looked at this function last time or the time before, I don't remember. This is the graph of arctangent or tangent inverse with asymptotes y equals pi over 2 and y equals negative pi over 2. And this is a perfect example. As you see, this function at infinity has the horizontal asymptote pi over 2. But at negative infinity has the horizontal asymptote negative pi over 2. Good, so we always start by plugging it in and from the inner function, of course. So, when x approaches 0 from the right, please tell me where this is going. Do we see that? As x approaches 0 from the right, thank you, the function values get closer and closer to negative infinity. Is that clear? So this is negative infinity. Now we want to determine where is the function going when the inside or the argument or the independent variable in tangent goes to negative infinity. So now look at the graph of arctangent when its argument or x goes to negative infinity. Where does arctangent go? Careful. Negative pi over 2. Is that clear? As x approaches negative infinity, the function values approach negative pi over 2. Is that clear? Yes? Okay. That was it. We didn't have to do anything else. So now let's choose something with e.
Can we do 37?
37 it is. In 37 we have limit as x approaches infinity from e to negative 2x times cosine x. Okay. Before we plug in, before we talk about this, I'm going to present the function in this format. So now let's plug in. I'm having difficulties with cosine x. What is cosine of infinity? But cosine is the bounded function. What is the lower possible value that cosine can take? Negative 1. What is the highest possible value of cosine? 1. So the top is bounded, no matter what. It cannot be infinity, for example, right? Okay, what happens here? When x approaches infinity, 2 times x approaches infinity, and e to infinity is huge, and I divide a number between negative 1 and 1 by something huge, what do I get? 0. Y equals 0, horizontal asymptote at infinity. Uh, 34. Have we started to understand the mechanism of these limits? Do we feel a little bit better about limits?
Yeah, for sure.
Okay, very good. So let's move on to the next problem. So remember, we are familiar now with three indeterminate cases, 0 over 0, infinity over infinity, and infinity minus infinity. We're going to add 4 more to that list. Okay, so I was looking at 34. So this is limit as x approaches infinity from, I think it's e to 3x, correct me if I'm wrong, minus e to negative 3x, divided by e to 3x, and plus e to negative 3x. Okay, so let's see what situation we're facing now. When x approaches infinity, where does this go? And where does this go? And where does this go? And where does this go?
Wouldn't the 2 on the right both go to 0?
Indeed. The 2 on the right, because they're 1 over e to 3x will approach 0, 1 over 3 to 3x. This is 1 over e to 3x, 1 over e to 3x will be 0. This is e to infinity, e to infinity. So we know that this is the second indeterminate case that we looked at, infinity over infinity. And we cannot draw a conclusion. Not just yet. Like before, we're going to factor out something from the numerator and something from the denominator. What do you think we could or we should factor out?
E to 3x.
E to 3x, the most powerful, yes. It's not a recipe, so don't always assume that that's the case. Okay, so, but that's what we need to do right now. So e to 3x times what is e to 3x? Minus, from negative 3x, we subtract the power that we took out. From negative 3x, I subtract 3x. E to negative 6x. And 1 plus e to negative 6x. Let's check this. Make sure that this is understood. So when I distribute e to 3x to 1, I get e to 3x. When I distribute e to 3x to e to negative 6x, I copy the base and add the exponents. That's the rule. I multiplied two exponential notations with the same base. I copy the base and add the exponent. 3x minus 6x is negative 3x. The same thing here. Copy the base, add the exponents. 3x minus 6x, negative 3x. Agreed? What do you think we're going to do next? Where does this go?
Go to 0. Oh,
Good. And the answer is 1. 1 over 1. Do not disregard what is left in there. So this is y equals 1, horizontal asymptote at infinity only. This is what we checked. Questions for me, please? Questions? Okay, I'd like to look at an example in which we are given a lot of information. We have to organize everything and we have to come up with a graph. So these are problems 5 through 10, anything you want. You may not be able to see very well. Okay, 5 it is. Vicky decided to put me out of my misery. Thank you. She picked 5. Okay, as I couldn't fold it, I couldn't. Okay, 5 only has 3 conditions. Is that all you wanted? Just 3 conditions? So 6 has 6 conditions, 7 has 5 conditions. You want one with more conditions or just 3?
We can start with just 3.
Okay, let's start with just 3. Very good. That's perfect. So we are given that the limit of f of x when x approaches 0 from either side is negative infinity. We are told limit of f of x when x approaches negative infinity equals 5. And the last condition, limit of f of x when x approaches infinity is -5. One more time, let's sketch the graph of an example of a function that satisfies all the given conditions. Okay. I'm going to summarize this information in a table. If you don't like this table, just invent your own, but summarize it somehow. Summarize the information somehow. We're told that the limit from either side of 0 is -infinity. Here is 0. So the information one more time, limit from either side of 0 is -infinity. Done. Limit of f of x as x approaches -infinity is 5. Done. Limit of f of x as x approaches infinity is -5. Done. And now I'm ready. You can create your own graph. I'll create my own. It's up to you what you want to do. You can put a number in here if you want, put 4 or nothing. It doesn't matter. It doesn't have to be defined. At that point, you can create any function you want. So obviously, x equals 0 is a VA. Y equals -5 is a horizontal asymptote at infinity only. Y equals 5 is a horizontal asymptote at -infinity only. But I cannot just graph a little piece of it. So I'm going to graph 5 all the way, and -5 all the way. A function can and is allowed to cross its horizontal asymptotes. A function will never cross its vertical asymptotes. And it can also cross slant asymptotes, but not vertical. Okay, so from approaching 5 to -infinity. And from approaching, so from -5 now to, sorry. And from approaching -infinity to -5. That's our example. Oh, that's my example. You can come up with anything else. Any questions here? Okay, should we choose another or can we continue?
Can we go over 6?
Yes, of course. Let's do 6. Any questions on this problem? Any questions? Any questions? Okay, perfect. So that's number 6. Number 6 is telling us limit of f of x as x approaches 2 from either side is infinity. Limit of f of x as x approaches -2 from the right, I think. Limit of f of x, I'll check in a second, is -infinity when x approaches -2 from the left. I think I'm correct. The next one is limit of f of x is 0 when x approaches -infinity. Limit of f of x is also 0 when x approaches positive infinity. And they're telling us f of 0 is 0. I'm checking my numbers. Yes, 2, -2 from the right, -2 from the left. I think that's what I have. Yes, correct. And negative infinity the first one, and infinity the second one. That's it. Perfect. I highly recommend summarize all this information somehow, so you can make sense of it. Okay, so let's do that. Okay, we have 0. No, we only have, yes, we have f of 0 is 0. Done. Limit of f of x as x approaches infinity is 0. Done. Y equals 0 horizontal asymptote. At negative infinity is also 0. Done. So y equals 0 horizontal asymptote. Then we know something happens at 2. We are told the limit from either side is infinity. Done. And also something happens at -2 from the right-hand side, infinity. Done. From the left-hand side, negative infinity. Done. So obviously, x equals -2 and x equals 2 are vertical asymptotes. -2 and x equals 2 vertical asymptotes. And now I'm ready to graph. I took everything into account. Everything is summarized, and we're ready to graph this function. It's an example of a function. It's not the only correct answer. There is no need to graph the horizontal asymptote y equals 0 because that is the x-axis. But I have to graph -2 x equals -2 as one vertical asymptote, and the second one, x equals 2. And now I'm ready to plot. I will plot 0, 0. It says from 0 to negative infinity, no problem. Then from positive infinity, turning at 0, going back to positive infinity. That's really nice. A nice symmetric function. And then from positive infinity to 0. Not anymore. It was symmetric till the right-hand side came in. So this is it. This is f of x. It's not the only correct answer. Questions? Questions? I know I have 15 minutes left. I can introduce the final topic of this chapter, and I'll tell you what it is in a minute. Or we can continue practicing the limits. We go back to the handout with more limits. It's up to you. What would you like to do?
We have a quiz Thursday, don't we?
Say it again?
We have a quiz Thursday, don't we?
Yes, please.
And the last topic will be on that quiz.
It's going to be on anything we studied.
If it's on what we
Please.
studied, I'd rather go over the limits.
Okay, very good. Excellent. So let's go and, can I borrow the handout for a minute?
Okay.
Thank you. So let's go over more limits. On Thursday, we will be able to finish chapter 2. I would like to review everything next Tuesday, and I will let you decide whether you want to have the test the following Thursday or the following Tuesday. I don't mind either way. I'm kind of on track, so
The
it's
test isn't on this Thursday, like next.
the following Thursday. I'm gonna finish chapter 2 this Thursday, then we will always have a review session, and then the test. So we can make a decision at the end of the class on Thursday. Okay, perfect. So let's go back. So I think we covered one. Correct me if I'm wrong. If I forgot anything, let me know. We did not cover anything from 4, so that's an option. Let's look at the radical function first, number 5, and then we'll go back. Is that okay, everyone? So we have the limit. I'm going to copy it and give it back to you in right sec. So x approaches 4 from the left, from the square root of 16 minus x squared. Thank you. Okay, this limit will also ask us to, like the one with the absolute value when we were asked to simplify fully. Here, this limit will ask us to find the domain of the function first. So please keep that in mind. Don't even look at the limit. So this is our function. We had something similar a while back. We're asked to find the domain of this function first. So how do I find the domain of a square root? What do I have to do, or what do I have to write? It's a very good question. Don't forget what you want to say. Don't forget I just want to say something. The square root of 4 is only 2, nothing else. But sometimes we see that plus or minus, but that comes from solving this equation. When we move 4 to the other side and we take square roots, this side is the absolute value of x, so that's why we get x equals 2 or negative 2. Not the plus or minus does not come from the square root. It comes from the square root of x squared. So when we look at a square root function, remember the simplest square root function is this. What is its domain? What is its range? So the same idea here, we have a function that it has a square root on it. It's the same concept, nothing different. What do I have to write in order to find the domain of this function? We had it in the assessment. We had a function like that, and we talked about it. Sorry, Gobi, you wanted to say something. I interrupted you.
I was just gonna say what you're gonna say. That it has to everything inside the square root has to be greater than 0.
Or, yes, greater than or equal to 0. That is the starting point. Solving this inequality will give us the solutions or the domain of this function. I see that. Okay, so this is a what type of inequality?
Quadratic.
Excellent. It is a quadratic inequality, and I will have to rearrange it in descending order, and I will have to multiply by -1 both sides because it has a negative leading coefficient. Every time we multiply both sides of an inequality by a negative number, we have to switch the inequality symbol. The next step, please do not ever attempt to take square roots. The next step is to factor. And when we factor, we will use the method you like. I like to present this method. And of course, it's up to you. Use the method you like, as I said. So negative infinity to infinity, and this is the product we are studying the sign for. And we know that x plus 4 is 0 when x is very good. And this one is 0 when x is 4. We've done this before. 0, 0 when I multiply them. Both of them have a positive slope. They come from negative infinity and go to positive infinity. So negative, positive, negative, positive. I multiply two negatives to get a positive. I multiply a positive and a negative, and that's it. Only now I look here and ask myself, what do I pick? Which sign is less than or equal to 0? But we know there is only one sign that is less than or equal to 0, which is negative. So then the domain of this function is this. So the domain of this f of x is between -4 and 4. Now I look at the limit. And we were asked to find the limit as x approaches 4 from the left of this. And what would you write? You will write is 4 from the left in the domain?
Yes.
Perfect. Please plug it in and tell me the answer. Excellent. What if I ask now limit as x approaches 4 from the right of the square root of 16 minus x squared? What would you say now?
Doesn't matter.
Exactly, because the function is not defined on the right-hand side of 4. Great job. Well done. Thank you. Any questions on this? Is this okay? Any questions, please? Anyone? Can I copy the next one? This is a super, super, super important limit. We are going to be able to determine this very easily. Not now. Thank you. At this point, we're not able to. Here's what we need to do. We will be able to very soon in the next chapter. But here's what we have to do next. Sine x over x when x approaches 0. Ready? Let's put the function in. Clear whatever you have. So sine x, close the parenthesis, and divide by x. Since we only have one term, there is no need for parentheses around the denominator. And the viewing window, what do I care? Where do I want to see this function? Near
0.
Near 0, very good. So negative 1 to 1 is good enough. With a scale of 0.5, that's good enough. How low? I already see it here, but I'm just going to say negative 2 to 2 with a scale of 1, and then graph. So negative 1, 1 with a scale 0.5, negative 2, 2 with a scale of 1. Everything okay so far? Okay, so let's graph. Here it comes. As x approaches 0 from either side, the limit is
0.5, right?
1.
I thought it was 0.5. Oh,
Is that clear? But now what do you think will happen when I plug in 0?
Just gonna read error.
Of course. But who cares? The function doesn't have to be defined at 0. The limit still exists. So the function does this. This is the right branch. This is the left branch. It does this. The limit is still 1. We will be able to prove this very easily, but not today. Algebraically, using calculus, I should say, better. So the limit is 1. Also, the multiplicative inverse, x over sine x, when x approaches 0 from either side, will also be 1. This is a super important limit. Okay, can I look at one more? So please remember, at this point, we could not prove it with anything else but the graph. Let me see on the back. Now we are capable of, and we have all the tools to work on the limits to infinity. Okay? Actually, I should write here better at. So please correct that. Limits at infinity, please. Okay, so please choose. We have time for one. The bottom one, very good. He's choosing again. Told you. Just kidding. Oh, sorry. Did I do that? Sorry about that. So we have limit as x approaches infinity, x minus the square root of x squared minus 4x. Same idea with the one that we just looked at earlier today, but a little bit more human. Okay, we have to plug it in. What do we get? Where does this go when x approaches infinity? Minus. Where does this go with the whole thing? Good. So it's an indeterminate case. And the previous one, what did we get? What was the answer when we had the infinity minus infinity? What was it, 2 or something? No, a minus b over 2. Would you have guessed that infinity minus infinity ends up in a minus b over 2? No one would have. Okay, very good. So then the same idea, what do I need to do? The conjugate, yes. Rationalize the numerator into with x plus the square root of x squared minus 4x and x plus the square root of x squared minus 4x. Same way. It's a very good practice. Actually, thank you for choosing that. I'll copy the denominator, but now I know what I have to do, so I'm going to immediately factor out what under the square root.
X squared.
Yes, because that's the degree. And then we'll find in a minute what to write in parentheses. Can anyone give us the numerator?
X plus,
It will be x squared,
X squared.
yes, minus, in parentheses, x squared minus 4x, right? Because it's a squared minus b squared. X squared minus the square root squared. Any questions? Do we see this? Are you okay? Are you with me? Okay, so then the numerator will be limit as x approaches infinity, x squared minus x squared plus 4x. And the denominator will be x plus, when I take the square root from x squared, what do I get? When x approaches infinity? X. And in here we have 1 minus 4 over x. And the square root. 1 minus 4 over x. These two go away. The numerator is 4x. And of course, I will factor out x in the denominator. 1 plus the square root, 1 minus 4 over x. Yes, x will go away now. At this point, I do drop the limit operator. The numerator goes where? To what? The numerator goes to, there is nothing else but 4, so there is nothing. Where does 4 over x go? Only when x approaches infinity or negative infinity. Where does the denominator go now? Very good. So then the limit is 2. So then y equals 2, horizontal asymptote at infinity only.